Hello, and welcome to Module 7.5, Systems of Inequalities. Our objective for today is that I can solve system of inequalities by graphing. What is a system of inequalities? It is two or more inequalities with the same variable. And how do we represent these inequalities? What do we see the solutions as? They're a set of ordered pairs that satisfy all the inequalities in the system, and it is the overlap of the graphs. Right? So remember, a solution to an inequality is a region. It's an entire region that any of the values within it are going to satisfy it. In a system of inequalities, you're looking for an overlapped region where points are going to satisfy both of the inequalities that you're looking at. All right, so how do we go about doing this? We need to graph, and it's all that we've been doing with graphing lately is the same. So we need to find our slope and our y-intercept. And we need to know, is it going to be solid or dashed? This one is going to be solid because it is greater than or equal to. And we're shading above because it's greater than or equal to. So we're going to put in our points. We got a point at 5, and it's a -1 slope. So we're going down 1 and to the right 1 with each step that we take. And then we draw in our line, and we are going to shade. Like I said, it is going to shade above. But we can always use a test point. Is 0 greater than -0 plus 5? So is 0 greater than 5? Yes, it is. So, or it's not, sorry, it's not. So we're going to shade the side that does not have 0, and we shade above. So that's our first line. Our second line, we're going to find we have a slope of 3 and a y-intercept of -4. So we start at -4, and we're going up 3 and to the right 1 with each step we take. Up 3, right 1, up 1, 2, 3, right 1. And we draw in our line. And we need to do our shading. And again, we're going to use that same test point of 0. Is 0 less than 3 times 0 minus 4? Is 0 less than -4? No, it's not. So we shade the other side, which is below our line. And when we look at this, when I release the marker, you're going to see that we have an overlapped region where it is satisfying both of the inequalities. That darker area here is going to be satisfying both inequalities, right? So any of the points in that area can be a solution. So let's pick one of them. I'm going to pick the 0.55. So is 5 going to be greater than or equal to -5 plus 5? So is 5 greater than or equal to 0? Yes. Is 5 less than or equal to 3 times 5 minus 4? Well, 3 times 5 is 15, minus 4 is 11. Is 5 less than or equal to 11? Yes, it is. So it works. All right, now let's take a look at some other examples on the next page. Letter A, we have y is greater than 3x minus 2. So we're going to start off. Our slope is 3. Our y-intercept is -2. So we're going to put a point at -2. And our slope is 3, so we're going up 3 and to the right 1 with each step. And we're going to draw our line in. Arrows at the end. And it is greater than, so it's going to be a dashed line. So for me, it's easier to just draw the line in and then make it dashed by erasing some parts of it. And now we need to shade our inequality. It is y is greater than 3x minus 2. So let's check with 0, 0. Is 0 greater than -2? No, it's not. So we cannot shade the side that has 0. So we're going to shade above it. We're going to shade above it because 0 is greater than -2. right? So we shade that area in. All right, so now we're going to go to our next one. We have a slope of -2, and our y-intercept is 5. So we put our point at 5, -5, so or +5, so we have a point at 5, and we're going down 2 and to the right 1, down 2, 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 right 1. And again, this is going to be a dashed line. So I'm going to try to just draw it in as dashed. It won't be as perfect, but it's all right for me. So if we are drawing this in, now we need to use our test point. Is 0 less than +5? Yes, it is. So we're going to shade below this line. Okay, and we're going to see the overlap section appear. And it's going to be that area that's bounded on the left-hand side there. Okay. All right, let's look at letter B. We are going to go with our first one. Y is greater than or equal to -x minus 4. My slope is -1. My y-intercept is -4. So I have a point at -4, and my slope is -1. So it's decreasing 1 and going to the right 1 every single step. And we have our line drawn, and it is a solid line because it's greater than or equal to. If you're unsure where you put that solid line or dashed line, if it's got a solid line under the inequality symbol, it is going to be a solid line in the graph. Y is going to be greater than or equal to -x minus 4. So we're going to be shading that one above, or if we use a test point, 0 is greater than or equal to -4, and that is true. So we're going to shade our region above in this one. Okay. You don't have to be perfect in your shading. As long as it's very clear which area you're shading, you're good. All right, now let's use our next one, and we're going to go with a slope. Well, actually, this one is y is less than or equal to -4, so my slope is 0, and my b value is -4. So I'm going to put a point at -4, which I can't quite do because of where the line is, but this is going to be a horizontal line at -4. And we are saying that y is less than or equal to, so it is below this line that I'm going to shade. And so when I do that, we're going to see the area magically transform. Hey, look, cyan plus magenta gives us blue. This is a little bit of a sneak preview of what you're going to be doing in science class when you return from winter break. All right, I want you guys to do letters C and D on your own. These are 2 you-try problems. Graph those on your own and then check your answer against mine. All right, letter C. Let's take a look at it. First of all, my slope for the first one is -2. My y-intercept is 3. So I put a point at +3, and it's -2. So we're going down 2 and to the right 1 with every step that we take. And we draw in our line. All right. And we have some shading to do here. So where are we? We have less than. Oh, that's right. It's less than. So it's a dashed line, not a solid line. And it's less than, so we're shading below it, but we can always use a test point. Is 0 less than 3? Yes, it is. So we're going to shade below it. All right. And once we fill that in, we'll be able to go on and graph our next one. All right, so with our next one, we have a slope of 1/2, a y-intercept of -2. So I have a point at -2. the slope is 1/2, so it's going up 1 and to the right 1 or right 2 with each step. Up 1, right 2. Remember, the sign tells us whether we're going up or down, and that'll be our numerator. And then the denominator tells us how many steps we're taking to the right always. So we draw our line in, and we are going to shade now. So when I shade this, y is greater than or equal to, so we should be shading above, but let's use a test point and verify. Is 0 greater than -2? Yes, it is. So I'm going to shade this one above in this region here. And we're going to see our overlapped section. Hey, magenta and yellow gives us red. That's kind of interesting. All right, letter D, let's take a look at what's going on here. We've got something interesting. So first of all, my slope for the first one is 0. My y-intercept is -3. So that's a point down here at -3. And my slope is 0, so I'm just going to the right 0, or 1 and up 0. But we know that better as a straight horizontal line. And when I shade that one, we have it is less than, so I'm shading that below that area. All right, now my second line, we have y is greater than or equal to 1, so m is equal to 0. My b value is 1, so I have a point at 1, and we're shading it, and it's going to be a horizontal line. And we do need to double check. So this one was greater than or equal to. The first one was less than, so it's going to be just a dashed line. But my greater than or equal to, we're able to shade above it, and it is a solid line. So what's happening in this case? Do we ever have, we've got two lines that parallel, right? They have the exact same slope, different y-intercepts, so they're parallel. Will they ever intersect? No, they won't. They'll never intersect. So this is an example of no solution. If they're parallel and they're shaded in opposite directions, it is going to be no solution because there is nothing that is going to be able to satisfy both of those inequalities. All right, let's take a look at example 3 where we're going to do some applications. So the first thing is we have a dog walker, and the dog walker is going to earn $15 per hour doing that. Let's see, she also earns $12 per hour for babysitting. She wants to earn at least $300 next week, but can work no more than 30 hours. So let's look for and highlight some important information. So first of all, I notice that I'm given a rate here. Dog walker makes $15 per hour. She's earning $12 per hour for babysitting, and she wants to earn at least $300 next week. So those things definitely look like something that I can stitch together, right? Standard form of an equation. We have two different rates. Relating the same variable is equal to that same value, right? It's equal to that same unit. So we have dollars and dollars and dollars. Okay. Well, what about what else is there? She can work no more than 30 hours. No more than 30 hours. That has to be less than 30 hours. And we want to know what graph is going to show how many hours she can work. Well, we need to write these two equations first. Now, what I always want to do when I do a word problem is I want to define my variables. So I'm going to say that x is dog walking. We'll just abbreviate that DW. And y is going to be babysitting, BS. All right, so if x is dog walking, so we're going to have 15 times x plus $12 for babysitting times y. We want it to be more than or at least 300, so greater than or equal to 300. Our second inequality, she can work no more than 30 hours. So the hours dog walking plus the hours of babysitting has to be less than or equal to 30. All right, now how do we graph with standard form again? We need to find the intercepts. That's our best way of doing it. So if we substitute in 0, we're going to get that x is less than or equal to 30. So if she only worked dog walking, she could do 30 maximum. And if she only did babysitting, it would be 30 maximum. Okay, now we need to look at our other equation. If we did 15x is going to be greater than or equal to 300. So if she only did dog walking, what could she do? She would have to work at least 20 hours. And if she only did babysitting, we would divide by 12. And so y would be greater than or equal to 25. So if she only babysat, she'd have to work 25 hours. If she only dog walked, she'd have to work 20. And she has to be a maximum of 30 hours. So on both axes for the red one, it'll be at 30. Now let's take a look at the graph that I've done already. So I already set up my units. I went with a scale of every line is worth 5 on my grid for the x-axis and the y-axis. So 5 hours per line. We have dog walking on the x-axis, babysitting on the left, on the y-axis. Make sure that when you are doing your own work, you have those things on your graph. You should always label your units, and you should always label your scale on your graphs. Always. That is the expectation. So now let's graph our blue line first. We know that x has to be greater than or equal to 20, so we're going to go and put a point at 20 on the x-axis. And x has to be greater than or equal to 25, so we're going to put a point on the y-axis at 25, and we're going to draw a line between them. Do we need arrows at the end? Well, the answer is no, because that would put us into negative hours in one direction or the other. You can't have negative hours. We are greater than or equal to, so that means we are shading above this line. Okay, and I'm going to widen that out a little bit so it goes a little faster. So we're shading above the line that we have here, right? And it doesn't have to be perfect. If there's some spots, that's all right. So now what do I do with my second line? So x had to be less than or equal to 30, and y had to be less than or equal to 30. So I'm going to put points at 30 on both axes, and I'm going to connect them with a line. And that ended up being a little curved. We're going to draw a straight line. All right, that's a little better. And it has to be less than 30, so we're going to be shading below the 30 line. Okay, and again, you're going to see we have an overlapped section. In this case, it's going to be this sliver right here is the possible number of hours that she could work where she's within her 30-hour limit, but she is also going to be making the $300 that she was hoping to make. So something like 10 hours dog walking and 15 hours babysitting, or 20 hours dog walking and 5 hours babysitting. Those would fall within that range of what we're looking for. All right, letter B. You want to build a fence for a rectangular dog run. Okay, so that seems like an important piece of information, that it's going to be a rectangular dog run. All right, and we want to know, you want the run to be at least 10 feet wide. Well, that seems pretty important, at least 10 foot wide. We want it to be at most 50 feet long, and we have 120 feet of fencing. We want a graph of this dog run. Well, before we can write any equations, we need to know what our variables are going to be. And we're talking about a rectangle, and we're talking about a fence around it, so we're looking for perimeter. So perimeter, usually we're working with length, so x will be length, and y will be width. All right, so now let's look at this, and really notice I had an extra color added in here, so that might be a little bit of an indication that we have 3 inequalities that we're going to write here. So if we want the run to be at least 10 feet wide, well, y is the width, so y needs to be at least, it needs to be greater than or equal to 10. Okay. Our next sentence says the run can be at most 50 feet long. So the length, x, if it's at most 50 feet, it has to be less than or equal to 50. All right, and we're told we have 120 feet of fencing. So 2 times the width, or 2 times the length, plus 2 times the width has to be less than or equal to 120. That's our formula for perimeter. 2 times the length, 2 times the width, right? If you think about it, it's x plus y plus y. So that's where we get the 2 times for both of those. And that has to be less than or equal to 120 because that's all the fencing that we have. So in order to graph this, I want to look at what is my intercepts. So we have 2x is going to be less than or equal to 120. And then we divide by 2. We have x is less than or equal to 60. And we have 2y has to be less than or equal to 120. Divide by 2. And y is going to be less than or equal to 60. So now we need to pull all these three things together. So y is going to be greater than or equal to 10. Well, first off, let's look at what did I do for my graph. We have length on the x-axis because it's the x variable. We have width on the y-axis because it's the y variable as we defined them. I went by 5s on my graph yet again, so it took me all the way up to 75 on the x and 75 on the y. So my first one, I said that my y is going to be greater than or equal to 10. So that has a horizontal line at 10. So when I put my point at the y-intercept of 10, the slope of 0, this one will have an arrow at the end because we can go to infinity in that direction. Does it make sense that way? No, but we can, so we're going to draw it. So we are shading above because it has to be at least that far. Okay, and one thing you could do on these kind of problems, if you are not using colors, you could do like a cross-hatching like this, where you are showing where you're going to be putting that, one direction. All right. All right, so now let's look at the next one. X has to be less than or equal to 50. Well, that's going to be a point at x-intercept of 50. That's going to be a vertical line, right? Because an x equals line is vertical always. And it is less than, so we're shading to the left. Okay, and I'm going to shade that in. We'll fill in our box. And we can see where we're starting to overlap a little bit. And my third one, I have x is less than or equal to 60, y is less than or equal to 60. So I'm going to start with points at 60 on both of my axes, and I draw the line in between them. And I am shading, it is less than, so I'm shading below it. So when I shade below that line, we get the region that is right there. So this area right here is going to be my overlapped region. Right? That triangle represents areas or lengths and widths of the dog run that would meet the two criterias of at least 10 feet wide and at most 50 feet long, while still remaining within the 120 feet of fencing that we have available for us to use. All right, now let's look at our last one, letter C. Cherries cost $4 per pound. Grapes cost $2.50 per pound. You can spend no more than $15 on fruit. Well, those are definitely rates, and we have no more than 15 on fruit. So some sort of fruit salad. All right, now you need to at least 4 pounds in all. Let's define our variables. X is going to be cherries. Y is going to be equal to grapes. All right, so my first equation, we're going to stitch the money together. We have 4x plus 2.5y has to be less than or equal to 15. And let's go ahead and find our intercepts right away. 4x is going to be less than or equal to 15. So if we only bought cherries, divide by 4, we could have, if we only bought cherries, we could have 3.75 pounds of cherries. If we only bought grapes, divide by 2.5, y would be less than or equal to 6. So we'd be able to buy 6 pounds of grapes if we only bought grapes, and we could buy 3.75 pounds of cherries if we only bought cherries. My second equation, or second inequality, is going to be x plus y, the grapes plus, or cherries plus the grapes, is going to be less than or equal, or no, sorry, greater than or equal to, because we want to have at least 4 pounds. So that means x is greater than or equal to 4 and y is greater than or equal to 4. Those are my two intercepts if we graph based on standard formation or standard format. All right, let's take a look and graph it. We are going to put our points at 4, and you'll notice cherries on the x-axis, grapes on the y-axis. I went by 0.5 per line, so half a pound per line, and I only labeled every other, so I labeled the full pound amounts. The cherries, we could have 4, we needed a minimum of 4. Okay, so we had 4 and 4. Draw the line in between them, and we needed at least 4, so it was greater than or equal to. So we are going to be shading above our line in this instance. Okay. And our blue line, we had x is less than or equal to 3.75. So if each line is a half, there'd be 3.5 would be there. So 3.75 would be halfway between 3 and, or the 3.5 line and the 4 line. And we could have 6 pounds of cherries. And we have our straight line. And it was less than that amount. So I'm going to be shading below the blue line. And so we see we just have this tiny little sliver there that we are able to purchase within while meeting our cost criteria and our amount of cherries for whatever fruit salad or thing that you're making. All right, so let's take a look at our next page. Write a system of inequalities from the graph. So let's take a look at the red line first. The red line, I see I have a y-intercept. My b value is 1. My slope, I'm going up 1 and to the right 2 with every step that I take. Up 1 to the right 2. So if we're going up 1 and right 2, our slope is 1/2. It is a solid line, and we shaded it below the line. So let's write that inequality. Y is going to be less than or equal to, because it's solid, our slope 1x, our slope is 1/2 x plus 1. Okay, y is less than or equal to 1/2 x plus 1. Now the blue line that I look at, again, it's got the same y-intercept. So our b value is still going to be 1. What's my slope doing, though? I'm going down 1 and to the right 2. So it's -1 and right 2, right? I'm going down 1, right 2 every single step that I take. So my slope is -1/2. It is a dashed line, and I'm shading below. So it's going to be y is less than only less than because it's dashed. We have our slope, negative 1/2 x, my y-intercept, plus 1. So those are your two inequalities for that graph. All right, let's take a look at letter B. For this one, your graph is only giving you the overlapping area, so you have to do a little bit of intuition of what is actually happening here. So let's look at the red line. We have a y-intercept. Our y-intercept is -2. My slope, what's happening with it? I'm going up 1 and to the right 1 each and every step. So my slope is 1. And where am I shading it? Well, if my overlap, if we're looking at our overlap, I'm seeing that my overlap has to be above the red line, right? So we're shading this one above, so it's going to be greater than. So we write our inequality. Y is going to be greater than or equal to, because it's a solid line and we're shading above, our slope, 1x, minus our y-intercept of 2. All right, let's take a look at our blue line here. All right, we have our same y-intercept, so our b value is still -2. My slope, though, instead of going up, we're still going up, but I'm going up 1, right 3. Up 1 and right 3. So it's a 1 and a 3. So my slope is 1/3. And where am I shading? Well, everything that's in the overlap is below that blue line, so it's also dashed, so y is less than 1/3 x minus 2. Now, over here with the red one, if you had just written y is greater than or equal to x minus 2, that is an equivalent expression. That is true. I would accept that in your answer as well. You don't have to write the 1 for the slope, but it would be acceptable. All right, I want you guys to try letter C and D on your own and then check your work against mine. All right, for letter C, we have our red line. We have a y-intercept. Our b value is -2. My slope is -1, right? We're going down 1, right 1 each step that we take. It's solid, and we're shading it below. So we have y is less than or equal to -x minus 2. My blue line, I'm crossing my y-axis at 3, so my b value is 3. I'm going up 3 and right 1 each time. So my slope is 3. It's solid, and I'm graphing above it. So it's going to be y is greater than or equal to 3x plus 3. Now, letter D asks you in problems A, B, and C, is the intersection point of the two lines part of the solution to the system? Well, let's look at this. And I'm going to erase some of my writing over that line so we can look at it, right? Let's zoom in on that intersection point. We have a solid line interacting with a dashed line. And what did that tell us again? A solid line, all of the points on the line are part of the solution. A dashed line, all of the points on the line are not part of the solution. So is that intersection point a solution? Well, for letter A, the answer is no, because one is dashed, one is solid. In letter B, one is dashed, one is solid. So letter B is no. And letter C, they are both solid lines, so they're both equal to equations. So letter C is yes. All right, you can stop with the notes there if you are ready. If you would like to see me do a couple extra examples, there's 4 more examples in these notes. If you want to watch me go through those, stick around and I'll go through them. All right, letter A, we have a slope of 1, a y-intercept of 2. So I put a point at positive 2, and I'm going up 1 with each step that I take. And I draw my line in, and it is less than, so I'm going to be shading below this line. All right. So we have our line shaded below. My second inequality, my slope is 1. My y-intercept is negative 3. Ooh, we've got parallel lines here. And we also need to point out that the red one was less than or equal to, so it's going to be a dashed line. All right. And I'll fix up some of that shading right there along the line. All right, so now this is a dashed line, and we need to figure out what is going to happen here. So, do this. My y-intercept is at negative 3, so I have a point at negative 3, and my slope is 1. So this is an instance where, when we looked at that no solution one, we said that they were parallel and shaded in opposite directions and didn't have an overlapping section. These right here are going to be parallel, but there is an overlapping section because they are shading in, towards one another, right? So you still will have this sliver in the center that is an overlap. All right, let's look at letter B. Okay, I'm going to graph the second one first because that is a dashed line. So let's go with our slope is equal to negative 1/2, and our y-intercept is 2. So I'm going to put a point at positive 2, and my slope is negative 1/2. So I'm going to go down 1 and to the right 2 with every step that I take. And when we go ahead and we graph that line, we get that. And it is dashed, so I'm going to erase little bits of it so that it looks like it's dashed. All right, now we need to shade this. It is less than, so I'm going to shade it below. Okay, my second, or rather the first one, I just didn't want to deal with the erasing of parts of the graph. My slope is negative 5/2. My y-intercept is negative 2. So I put a point at negative 2. My slope is negative 5/2. I'm going down 5 and to the right 2. I can only get 2 points going in that direction. So I'm going to work my pattern backwards, and I'm going to go up 5 and to the left 2. And that gives me a couple more points that I can work with in creating the line. All right, and we have that. And we are told that it is less than or equal to, so we are shading below this line. And we can see that kind of pinkish area that's going to come through, or that more vibrant red area. All right, letter C, we need to solve that first one and put it in slope-intercept form, or we could graph it using intercepts. But I see that it's going to be a fraction, so I'm not going to want to deal with that. So let's just put it in slope-intercept form. I'm going to subtract 4x from both sides. And we get we get y is going to be less than negative 4x plus 2. So my slope is negative 4, my y-intercept is 2. So I'm going to put a point at 2. My slope is negative 4, so I'm dropping down 4 and to the right 1 with each step. Down 4 and to the right 1, and we are going to graph our line. And it is, y is less than that, so it's a dashed line. And it's less than, so we shade below. All right, our second one, we have a slope of 0, a y-intercept of -2. So put a point at -2, and it has a slope of 0. So we have a horizontal line, and it is y is greater than. So we are going to take some little pieces out of this line, and I will fix the green shading just because. And we are going to shade this one above because it's greater than. And when we fill that in, we see that kind of dark green patch that is our solution set off to the upper left. All right, letter D, we need to solve both of these inequalities for our x value. So I'm going to actually do the solutions down below. So I'll rewrite them. So we have 3x plus 2y is going to be greater than or equal to -2. So I subtract 3x from both sides. 2y is greater than or equal to -3x minus 2. Divide by 2, all three parts. We get y is going to be greater than or equal to -3 halves x minus, sorry, that was divided by 2, minus 1. Okay, my second one was originally x plus 2y is less than or equal to 2. I'm only rewriting it down on the bottom here because I didn't have enough room up at the top. So we have 2y is less than or equal to -x plus 2. And then we divide by 2 all three parts. And y is going to be less than or equal to -1/2 x plus 1. So we're going to go ahead and graph these two equations. -1/2 x plus 1, so we have a point at 1. That's -1/2, so we're going down 1 and to the right 2 with every step that we take. And so we graph that like so. Both of these are equal to, so they are going to be solid. And for this one, y is less than or equal to, so we're going to shade down below. And our second inequality was y is greater than or equal to -3 halves minus 1, so I have a point at -1. And the slope is -3 halves, so I'm going down 3 and to the right 2. Down 3, right 2, down 3, right 2. And you're going to draw your line in. And you're going to shade. So if I'm going to shade, it is greater than or equal to, so I am shading above. And we're going to see that sliver in the bottom right-hand corner of the graph is going to be where our overlapped region is. All right, that is the end officially of the Module 7 notes. If you have any questions, please bring them to class. Otherwise, I hope you have a great day.